going on where it's like it's hard to go ahead and get started here. This is data analytics here, and it's I'm very excited to hear about today's course. Basically, what we're doing is this is still the introduction here, so we're going to start some of the actual analysis stuff next week, but I wanted to spend some time today to talk about tools. And so if you go to, for instance, my, oops, not this one here. Sorry, it's this one here. If you go to the, oh, well, actually, I'll talk about this too while I'm there. I'll put out this particular, this is our Slack channel link here. I'll put this out in our channel here so that, for instance, if you wanted to chat or ask a quick question or whatever it may be, you can use Slack to do that. And basically, what Slack is a system of it's like a chat, if you will, but it's a chat that will connect all of us here in this classroom together. And so, what you'll do is you'll have to download a client for your phone if you're using chat or a Slack on your phone, or I would recommend downloading the client for your computer. But basically, though, if you have like a quick question or whatever it may be, rather than sending out an email, you can send in you can send out a chat. And I'm also inviting everyone to use chat to connect with their technical leader of the course here. And so, for instance, we have Declan Casey and Lancaster Wu, who are our technical leaders for this course. And they will also have the Slack chat on their phones or on their computers too. And so during the lab, for instance, and we do have a lab tomorrow, please don't forget about that. Please do come. But during the labs, though, we are going to have, we'll all be connected by Slack here. And so I'm hoping that this will help us to, even though we're apart from each other, we're not actually physically in the same room, we will be able to still connect with each other. And so I'm thinking that it's a good solution here. But I would say, though, that especially with me, for instance, don't send me a Slack message at like 3 in the morning and expect me to respond. I say this because I think it was like last semester or whenever it was, or the semester before that, I had a student who was really an all-nighter, and he would send me these text messages like on like questions for his homework at about like 3:30 in the morning, and then like another question at like 4 saying, "I'm still waiting for your response." And I thought, it's 4 in the morning. So like in the morning when I found his Slack messages, I found like one at 3:30, one at like 3:45, one at 4, and they're all asking like, "Where's my answer?" And like, I'm sorry, I fell asleep. I didn't mean to fall asleep on your time there. But anyway, so please don't send out messages like, well, you send them out when you want, but don't expect an answer until like working hours. And I think that goes for your technical leaders too, because they also need their sleep. But please do spend some time getting to know Slack, though. I think this is a very good channel for us all to use. And I think it'll help us to stay connected. And so I'm very happy to have that. What I'd like to do next is I'd like to talk about some slides that we're going to be working with here. So I'm going to transition you, and hopefully when I transition, it doesn't make anyone feel like they're going to pass out. But these are the slides that we're going to, the new slides are up there. And I've added a couple of things actually to the data analytics page here. If you get onto the bottom here, you'll find, for instance, today we're going to be talking about a tool called Docker. And Docker is actually a very important tool in that you can use it to basically build an environment where you can run code. Now you're probably thinking, what does that mean? Well, when you run code, for instance, if I were to design some kind of code, if I were a software developer and I'm writing code here, and I run code on another person's machine, I need to know that that code is going to run exactly as I have created it here. And so what that basically means is that I need to know that the code is actually going to be able to perform. I need to know that the libraries are all the same, that the software editions are the same, everything is the same on that other person's machine. And so what Docker does is it's called, it's a container system here. And so what it does is it will open up this container or this place in memory on someone else's machine, which looks exactly like my place on my machine. And so that I know that when you run my code, you're actually running it in an environment which is exactly the same. And so that's called Docker. And so I'm talking about this because we're going to talk about, I mean, there's more to mention than that, but basically that's the gist of what this thing is. But I have this link on my site here that if you click on this thing, can I run Docker? It doesn't run this because I'm running this in an emulator right now. But it says no for this thing here, but it should say yes on your machine here. And so you'd have basically a yes or a no. In fact, I'm not sure why that's saying no right now, but it's probably because I'm running this in an emulator, and so the Docker doesn't see what's actually going on in my machine. But on your machine, though, hopefully it won't say no, it would say yes, and so everything is okay. Another thing that I'm looking at is will my machine run the programs in my classes here? Now, this isn't just for this course here, but I'm actually adding this this piece of information for other classes too, in the computer science department. Over the summertime, we had a meeting where we were basically talking about what kinds of laptops are necessary to be able to, if you have, what kind of configurations you need to have for your computers to make sure that your laptop is actually able to run every piece of software that you could ever have in any of the classes here. And so basically that amounts to these kinds of specs. Now, for this course, it's not a big deal. I mean, if you don't exactly have these specs, then that's probably okay. It's not going to matter. But the reason why Windows is down here, though, and what this has to do with Docker, is that Docker does not run on Windows 10 Home. And so that's the thing here. So if you're running Windows 10 Home, please send me a mail or let me know, and we can find a solution to perhaps get you upgraded to the Pro or Enterprise or another version like that so that you can run Docker on your machine. And we are in this class going to be using Docker for, not necessarily for the analysis, but when it comes to putting together your homework, your submissions for your labs. In some labs, you'll be running something called Gatorgrader. And Gatorgrader is a quick check that basically goes through all of your work to make sure that everything that you're supposed to do has been included. And that's my way of helping students to know that their homework is actually all there. And one thing that really pains me is, for instance, having to deduct points for a stellar homework assignment. And there's nothing wrong with the work that's there, but having to deduct points because there's pieces that haven't been completed, like pieces that are missing, and that's just unfair. And so, Gatorgrader is something that we're going to be using to ensure that your homework is complete as it stands when you send it out. Anyway, you can look through these if you'd like and just kind of see what you think. But I think that actually the one thing I'm concerned about, though, for this course is Windows 10 Home. If you're using that, please let me know, and we'll see whether we can find some system of getting you upgraded here. Yeah. Anyway, let me know. Okay, moving on. Another link that I've added here are the technical leaders. Technical leaders are these advanced students. They're juniors or seniors. They've done very, very well in all of their computer science classes, and they're basically magicians that make fear and unrest and frustration disappear, which is just I mean, it's just amazing. They're amazing people. It's like if you go to if you're an Apple user, there's the Genius Bar where you go into the back of the Apple Store and there's like these people who know everything. You can even ask them, like, I'm having chicken tonight. What kind of sauce should I be producing for that? They know everything. Our technical leaders also know everything when it comes to computers. So you can always ask them questions if you're having some trouble installing things, or for instance, if you're having some trouble with writing your code. They know. Every class has a specific group of technical leaders here who know what they're they're actually working with a specific class. For our class, our technical leader is, where are you? We have Lancaster Wu. He's taken this class, and he did very, very well. He was one of the people who led most of the discussions in the class, which was actually very exciting. And then we also have Declan. Where are you, Declan? He hasn't put his picture up yet, but he's right here. And I think they're both computer science majors here. But what I'm saying, though, is that when we have our lab, though, they will be there and they will be hanging out on the Slack chat. And so if you have any questions over anything here, of course you can ask me. I'm not saying that you can't ask me, but if you can ask them too. And that makes things easy, because if you happen to have a question and I'm busy, you can quickly just ask that person, and they should be able to help out just as well as anybody else. Alrighty, are there any questions at all? If there are any questions, please let me know. You can always use, by the way, for this course, you can always use your chat and let me know whether you have any questions. I'm reading here from Zach, everybody, Windows 10 laptops work with Docker if you update it manually on the Windows website. Yeah, so that update manually, that's right. So thank you, Zach, for mentioning that. What Zach is talking about is that there is an activation code that you can purchase. We can actually help you purchase that. You just have to see us and talk to the department here, and we can find an arrangement here. But basically, though, you pay for an activation code, and that will then convert your Windows 10 configuration. It was free. Well, Zach, we'll have to talk. Come and let me know. I had to pay for mine on, well, actually it wasn't my machine here, but I had to pay for another machine that I updated over the summertime, which was Windows that we had for our computer, or our Windows machine. I don't actually use a Windows machine. I hate to say this, and so if you have Windows questions, you may have to resort to asking each other or your technical leader, but I'm really not a Windows user. In fact, I haven't really used Windows in a long time. I can help, I can try, but it'll take me some time to figure out how to do this. So we can work together on that. But anyway, what I'm saying though is that you do have to update your Windows Home, and then once it's updated, then you have this professional version of Windows, and then that runs Docker just fine. And so anyway, but Zach, if you're listening, please come and let me know sometime, like how you updated your computer. I'd love to hear.
Yeah, I'm still running Windows 10 Home with Docker on my machine. Like they just made it compatible, so you just have to update it to the newest Windows 10 Home version.
This isn't, so this is not like a special hack? You didn't have to like somehow go inside and change the kernel? And
no, I just looked it up if the Windows 10 could run with it, and the Docker website says it's now supported.
That is a real relief. I'm so glad. Thank you, Zach, for being here today. I'm going to write that down. Windows Home.
Yeah, I can tell you more about it after class.
Yes, please do. I think that would, please do. I would love to hear more about it. That is the one. If you look at some of the computer science faculty around the department here, you'll notice that some of us have like these big kind of bags under our eyes. It looks like maybe some of us haven't been getting our beauty sleep. This Windows Home Docker issue is probably the reason that we haven't been getting all that rest here. It's because of that. But we can talk either today or sometime for office hours, Zach. But thank you for mentioning that. That's very helpful. Thank you. Okay, so I'd like to move on then. So these are our technical leaders, and now you can ask them questions too. And I hope that they know about this, the Windows Home Docker thing too. I'll have to talk to them and find out if they know. Then they should be telling everyone else too. I'm going to go down to the extra resources part of the web page here, and you'll see that, for instance, I have added another slide here. And so this, I'm hoping that today is the last time I have to add slides to the website here, because we are going to be using Git. In fact, that's part of today's actual discussion. Is we're going to be talking about how you can install Git on your machines. Now, in case you haven't thought about Git for a long time, or if you've never heard of Git before, I am sensitive to that. Git is not something that everyone knows, but basically what Git is it's a system of sending files to and from the cloud, such that your files that you have on your machine, like in front of you locally, are exactly the same files that have been left on the cloud by whoever it is who's maintaining these files. Right. So. And I'm hoping that most of you know what these things are. But I don't mean to undermine anyone's intelligence here, but I'm really speaking to the people who are perhaps not computer science majors in our course, who may not know what these things are. And so if you do have questions over Git or any of the other things as we go through this course, I mean, not just today, but if and when these questions come, please don't harbor them. Please let me know, and I'd be glad to help or ask the technical leaders, or you can ask each other, or just grab any computer science person and say, you, talk to me about this, will you? And I'm sure that everyone will be able to do that. But what I'm saying Git, though, we have, for instance, our class docs repository here. And so class docs is going to be using Git. That's why I'm talking about Git with such energy today. But basically, what these links are ways that you can update your computer with all the files that I leave on the cloud for this class. So, for instance, when, I don't know whether I can show you my terminal here. Maybe I can find the way of doing it, showing you. Oops, not that. Shoot. I'm going to see whether I can show you my terminal and to show you what Git looks like here when you're running this thing here. How do I do this? Sorry, guys. I know this looks kind of silly here, but here. Where is that? I don't see it now. It's funny. Well, I'm trying to find a way of sharing my screen here. But basically, though, when you type in a command here, it's going to update all of your computer files locally with your with the changes that I've left online for you. Just trying to find out where my terminal is. Oh, here we go. I got it. I got it. Hopefully, you all can see this when I switch over to here. Shoot. No, not yet. There we go. Okay, so this is my terminal, and I keep all my, actually it's not here, but I keep all my files in something called repo, and then I have in there what is it, the year, I guess, after that, it's teaching. You might want to have a kind of a structure in your directory here, and we'll get to some of the stuff in a bit here. Oops, shoot. Teaching, and then I have, for instance, then I'll make a directory in here. I'll call it CS10 or 301, and then I'll put fall 2020 or something like that. And then I'll go into that directory here. And inside there, it's going to be empty. But so what I'm going to do now is, you can't really see, maybe I can switch over here. I can copy and paste, and hopefully this will all work where we are. But this is all one line, by the way. And hopefully this will work without any trouble here. And when I go back over here, if I go ahead and paste this in here, there we are. It clones, it does what's called a cloning job here. And cloning really means that it's going to onto the cloud where I'm keeping all these files, and it's pulling those files across as they are in the cloud. And how do those files get there? Well, I put them there. I put them there, or if you're working with other faculty or other projects in code development, for instance, there are other places where other types of reasons for leaving code online for people. But if you're a code developer and you want somebody to be able to get to your code and to see all your code that you put together and see your documentation, you would wrap everything up and put this on the cloud here at GitHub, and you'd use a command like this to actually get that code. So when I go inside this thing, what do I see? I see the class docs repository. And so if I go in there, I can see that I have lessons and the syllabus. And so for instance, the syllabus, by the way, CD stands for change drive. I don't expect everyone to know what these commands are just right at the minute here, but we'll learn these things together, don't worry. In fact, you may not have to worry about these commands too many times at all. But if you go inside syllabus and I type in ls to give me a listing of files, you'll see that I have the course syllabus in there. And so this is actually the file that I've put in there. But more importantly though, the files or I also have these lesson files in here. And so those are, that should be the slides here. And they're organized by week here. So first week is going to be, if I change drive and go into 01 week here. By the way, I can push the tab button on my computer to go through. And you'll see that inside I have the files themselves. And so these files are the PDF documents. And so every time we have class, I'm going to ask you to go to your repository here and basically pick up these files. And those files are going to be like your slides for the day. And these are the files which I like to think of as the core of the class here. And of course we have books and we have textbooks that we can read and some other things that will be giving you, some flyers and some other code. But the actual energy for this course comes out of these slides here. And so that's really what I'm looking at. But for today, though, you don't have to worry about any of this stuff today. I mean, the slides I've put on the online for you, so you can grab them. In fact, if you go to I've just lost my window here. I know you can see it, but I can't see it. But if I go to this link right here on the resources page, it's the same thing. That's all there, so that you can have it. But I think on starting on next week here. And by the way, next week we will start in person. I will be there. In fact, sometime between today and tomorrow, I'll be sending you an email with your group that you're going to be in, and that group, whether it's a Tuesday or Thursday group, that signifies the day when. I hate to say that when you can come to class, but it's the day that we'll have when you're planned to be in person. If you want. If you don't want to be in person, then you don't have to be in person. You can still you can study for this course however you think is safe and effective. The On that note, actually, so in person and in person. So when we have a Tuesday, the Tuesday group will be present and the Thursday group will be online. On Thursday, the Tuesday group will be online and the Thursday group will be present. Each class, I'm going to be recording the videos. I'm recording them right now. I'll give you a link also soon about where you can actually pick up all these videos. I'm thinking they'll be on a YouTube page, but I have to actually establish all that stuff first. But you will have the videos available to you, and so you can watch them. I encourage you to be a part of the class actually as we are, so you can be a part of the class like synchronously, which means that when we're all logged in, then hopefully you'll also be logged in. But I am sensitive to some of our students who are not on the same time zone here, and so perhaps for them coming to class at regular class time is just not very feasible. And so we have these videos, and so the videos can be watched. But I would also say, though, that even if you are in class, and even if you are online and the videos are being made, then you can still go back to these videos and watch them to kind of recap over things. If you sometimes it makes me seem like I'm some giant moth or something like that. But when I see like flashing colors and bright lights and things like that in classes, sometimes I'm so distracted that I forget what was said. And so having a video would be nice to be able to kind of go back and watch, and get some of these, to revisit some of these ideas. Anyway, enough said on that. I'll send you an email between now and tomorrow to tell you which group you'll be in, and also how you can find those videos. By the way, are there any questions about any of that? So I know this seems like a lot of things to digest. I will say this about this course, though, that if what I'm saying today about the terminal, about typing commands in, and GitHub and Docker and all these things, if they are not making any sense to you, please don't panic. Don't panic about these things here, because I will be talking about these things all semester, probably in the same capacity. And so by the time, by the middle of next week or after next week, these ideas will not seem so crazy. And the reason why I'm saying this is because when I first took a computer science class, like I was saying, my undergraduate degree is actually in biology, and my master's is in mathematics. It wasn't until my doctorate that I actually started taking like real computer science classes, like computer science theory and all that. When I first started taking these classes, a piece of me actually panicked on the inside because I didn't know what these terms were. I didn't understand what people were talking about. And so at my school, I did actually connect with some of my technical leaders or other people who knew about these things, and I just spent time talking to them, and that's how I kind of got through it. But don't panic, though, because answers will come. They always will come, and it's just they may not be present right now, but they will come, and you won't be you won't be left in the dark. Don't worry about that. And you can always ask me or the technical leaders if you have questions, and I'm there. But if what I'm saying, though, doesn't make sense today, then that's okay. Don't worry about it. Don't worry. I'm going to move into the slides now. Again, I don't know why this is. I guess I lost this, but I would like you, though, to spend some time. You could do it now if you want to, as you're listening. But I want you to spend some time. If you have, to install your Git client on your machines. Now, if you are using a Mac OS, and you've never used Git before, I think that if you just go ahead and type Git at your terminal, in other words, if you type it here, then I've already installed it here. But if I type in Git, then it will say, Mac will say, I've noticed that you've just typed in a command, and it appears that command hasn't been installed. Shall I install it? And then you would say yes. And when it installs that command, it's going to ask you whether you should install something called Xcode. Now, Xcode is the Apple software development suite, and so it's actually quite sophisticated. It has many, many functionalities. We're not going to use seemingly any of them except for Git, but you can use it to develop some fairly exciting code. and it comes with Git. And so if it asks you to install Xcode, which is their development suite, and you're using a Mac, then please do. I don't have any way of testing this on this machine. I'm using a Mac right now, but moving on to Ubuntu, there is if you type in Git at your terminal, which again is when I say terminal, I'm talking about like the screen here where I'm able to type in commands. That's the terminal. So if you're in your Mac, you can locate the terminal, and if you type in Git and nothing comes up, then there is a command sudo apt install Git, which is something you type in the terminal, which would allow you to install the necessary software to make Git run. It's going to ask you for your password, and so don't worry if you think, why is this computer being so nosy and asking me for a password? It's going to ask you for the password, and that's necessary because I think Windows is Windows is the same way too. But all of these machines don't install software unless, of course, you OK it, and that's because it could be a virus or something. So they want to make sure that you know what you're doing. But in this case, though, sudo apt install Git is good enough. That's how you'd install your Git. Now, if you have any trouble, if something is going wrong, then by all means, set up an office hour appointment with me, or for instance, tomorrow at lab, find your technical leader, or find somebody else perhaps who's done this before. Once you've done it once, you don't have to install Git again, unless, of course, if you change your computer. One thing I would like to add, though, is I did find there's a website out there called Digitalocean. They sell cloud-based technologies, but they do have a very decent tutorial on how to install and get Git running here. And so whether you're using a Mac or Windows or Ubuntu, you can still check out that link and see whether, for instance, there's anything there that could help you to learn how to use Git more effectively. I think that's enough on that. If you're a Windows person, Git also exists there. You have to check out this website here called Git for Windows. In fact, if I click on this, you'll get, if you have an icon that looks like this, then that's the right Git. There's other types of Gits that are out there which might be a little bit more robust. Maybe they're more exciting for what we need. We just need something very basic, and this is good enough. And so on this website, hopefully you can all see this, there's plenty of online help. You can read about like how to install it. Where is it here? Somewhere there, somewhere I saw it. I guess, is it here? Yeah, so somewhere I saw, yeah, so there are places, there are answers out here waiting for you if you have any trouble. But actually, though, what I would recommend is that if you do have trouble, a little trick that you can do in computer science is you just take the error message that you get, whatever it may be, whether it's from your code or whether it's from Git or whether it's from who knows where. You just copy and paste that directly into Google and you see what comes up. And chances are, I know it sounds really, really lazy here, but chances are somebody has put that error message into some kind of into a forum, or they've asked a question online and they've copied and pasted that same error in there, and you're likely to find your answers right there. Anyway, I don't think I'm saying anything that you don't already know. Anyway, okay, so there's that. So these are the oops, I think I just lost my slides. There we go. So anyway, you have these resources here, and so somewhere between like now and lab here, please find a way or find some time here to install your Git client here and test it on. If you've installed the SSH keys, which means basically these are keys that allow you to use the commands without having to type in your password each time, then you can use this. But actually, I tell you, I don't think you have to worry about keys with the class docs repository, because it's a public. I've created a public repository, so I think that anybody anywhere could pull this class docs repository and get all the slides from class, and that's okay. But there's another link I am offering here too. There's two different ways of actually pulling over your work. There's HTTP and then there's SSH. HTTP uses the same kind of protocols that your browser would use, and so it may be it may be easier to use. Maybe it won't ask you for your password in that case. But SSH is a more secure way of sending things, and so if you're using like private repositories, you'd probably have something like this, or if you use HTTP, then it'd probably ask you for a password. But try them both out and see what you think. I mean, like I was saying here, I was showing you my page here. or my editor. When I put my files together here, I mean, think of something that's like kind of structured here so that you don't lose your files. So for instance, like I was saying, I put my class docs into this repository here called CS301Fall2020. And so then I know that all the files that are in there concern my repositories. But it's up to you how you want to organize your files, and you probably have a system already. But for me, though, I would keep everything together by class, so it's easier to locate these things. But I'll tell you one more thing, though, about this repository, that if you lose your repository, if something happens and you've lost the files, it's no big thing. You just go right back to these two links here. You run the same commands as you ran previously, and everything is restored. You have all the files all over again. Basically what it does is it says, hey, I'm so-and-so's computer. What files do you have for CS301? And then GitHub would say, oh, I have all this stuff. And then it would send all those files to you, and then you have everything back. I'm going to we've talked about that. So the main functions or the main commands that we're going to be using in this class about Git, I'm just making a slide here because it's basically these 4 commands that you'll ever use in Git in this course, and probably for many of your other courses too. You have one command here called Git Pull. That's what I ran before, which actually allowed me to go to a website here and to pull or receive all the work, or not a website, but going to the cloud here, the GitHub cloud, and to receive a copy of the files which are actually out there. That's Git Pull. That's like your update command. Basically says, go out to GitHub. Anything new? Yes? Send it to me. That's what Git Pull does. But then you are also going to be using Git because when you submit your homework, you're going to be submitting your work to a repository too. And then I'm going to be, on my end, using this command to pull over your work so that I can see it. And so these are the commands you're going to be using. Git Add A basically looks around your repository of files, your directory locally in front of you, and finds out what files are new. What changes have you made? Any file that's changed, if you have thousands and thousands of files and you've changed only one of them, then this command will find that one file and say, this file has been changed. And so that flag, or that file becomes flagged. And then you write a next message here called Git Commit. This is a message that you can type in to kind of like categorize how that file was changed. I would say make your message meaningful, because when you are developing code, you're going to be using this kind of, developers use this tool all the time. And so in their commit messages, they'd say, I finally fixed the such and such algorithm, still broken, needs work, or something like that, needs work with such and such. And so then when somebody is going through the repository to pick up some work, or to just to pick up where they left off, they can see your commit and say, oh, I see that this part has been fixed, then something still needs work, I better go check on that. So there's that. And then you have this other file here, or this other command here called Git Push. And basically what that does is it puts everything that all your changed files into a suitcase, and it sends it to GitHub. And so then GitHub has a copy of everything. And so these three commands right here, and this command up here, that's 4 commands. Those are probably the only commands in Git that you'll ever need to use. Now, I wanted to include these Docker images right here. By the way, I don't mean to just keep talking. If anyone has any questions, please do let me know. I don't want to make anyone get cut off here. But if you have any questions, please let me know. But I'm including Docker here. You don't have to have this installed like right now, and we won't need this actually for another week or two. But you will need this to be installed eventually at some point. And so that's why I'm asking you to check to make sure that your computer actually can run Docker. Hopefully it can. If it doesn't, then come and see me or talk to one of your technical leaders, and we'll find out why it doesn't run it. But it probably just means you have to install something, and that may be just going to one of the Docker websites here. Now, our own Dr. Jumatinova has put together a video which is worthy of an Oscar nomination. This is a video which talks about Docker and how Docker can be used. I would recommend checking it out. It's very conclusive. There's another website you can use to get some help on what Docker is all about, the main Docker website. I don't know why this link is for the downloads is so huge. I'll have to change that. But anyway, but there's a download site here that you can use to go to Docker and actually download the software. The download is free. You don't have to pay for anything here. The software will just come to your computer. You just install it and run it. and then just follow the installation procedure, and it should be okay. There is a tutorial that Docker does provide, which is actually quite sophisticated, where once you've installed the software, then you run a command, which basically builds an environment on your local machine, which is then allows you to play with some of the functionalities of Docker. And so it's actually kind of an interesting scene here when you see that you're running your code on your machine, but somehow the code thinks it's on a different machine. It's actually kind of interesting to see that happening here. But there are some other, there's another link here that I've added here, which I just call Exploring Docker. You have this place that Docker set up called Play with Docker, where you can actually type in some commands and run things. And you have the idea that you're running software that believes that it's on a supercomputer and not your laptop. It believes that it's somewhere else. And that's kind of how Docker works. It creates a room in memory in your computer, basically, in which certain things are happening, and everything inside that room believes that it's in this environment, and there's nothing else there. So anyway, you can play with this and see what it is. Go to the website here and see what you think, and then if it's something you'd like to play with, then I encourage you to do so. These are the commands I think you have to type in here. Oops, I can't copy this all together here, but basically it's this command here. This command, by the way, is also on their website, and so it's nothing. I didn't grab this. I didn't write this myself. And then once you have this command run, you'll see that Docker will give you this is from your terminal, by the way, but once you type in that command in your terminal and everything's been installed, then you'll get some message to say to go to your local host, which is basically this, in your browser. And then that's how you interact with this. It's actually quite fun. The next piece of software that we're going to be using in this course is something called Atom. I know that many of you have seen this before, and so if you haven't seen this, Atom is actually a very sophisticated editor, text file editor. It's not just used for programming, because in this course, this is data analytics, and so you might get a lot of data that comes to you in a text file, and you need to work with that text file in some way. You need to maybe move that text around, or maybe change it from a completely raw text into some kind of formatted type of of columns or whatever it is. You're into some formatted mode here. This is called wrangling, where you need to change the data into something that you can actually load into your software. And so you might need a very sophisticated text editor to do that. And so I recommend Atom. Now, this is just one of many hundreds of thousands of editors out there. But as a department, though, we all basically have used Atom. Atom actually was developed by Git. That's why there's this little, I don't know whether it's a cat or an octopus or octocat or something. I'll have to write to them and find out what this thing is, though. It just looks really extraordinary. But every time I look at this creature, I'm like, what is that? I think they call it an octocat, but it comes from GitHub, though. And so GitHub has this they've made this editor, so it seems to work quite well for what we use here. But if you have found another editor and you've fallen in love with it, then I'm not going to break this relationship that you have with your editor here and force this upon you. There's other ones out there too that you could look at here. But in terms of like actually writing or actually an editor that helps you to write good code, I think Atom is pretty good. So when you get a chance here, please try and install your software. Look through the websites here that I've listed above here and read up on their help pages here. And if you have any questions here, let me know how I can be helpful here. One thing I will say, though, is that if we're using GitHub here we're using GitHub for your homework, basically. So when you send in your assignments here, you're going to need a GitHub account. I didn't mention that before, but I'm mentioning that here. Before we have the Git software on our computer, which allows us to use the, to actually log into GitHub here. But in order to actually use GitHub, though, you're going to need an account. And so you could go to GitHub here, and this is, I think, my account here, but you can log out. But basically, your account will look something like this. You log in basically into your account, and you'll have all your repositories. These are all your files you've created here. But basically, though, this is where your stuff is in terms of like your coding projects and everything. So there you have it. Between now and lab, please try and look into establishing an account on GitHub. Like I said, if you have any trouble, please reach out. There's help available. And also install your Git client here. This is another link for where you can find your Git a Git client, which is actually quite good. It's different from these links wherever it was here, I guess. Yeah, here. It's slightly different from those links there, but I think it still works out quite well. Also look into Docker, try to install that, make sure that that runs. If you have any trouble with that, it could be that your machine hasn't been updated. We'll have to talk to Zach about the home, updating home here. Sorry here. I'm sharing a blank screen. I'm so sorry, guys. Is that true? Oh, this has crashed. Oh, there we go. That's extraordinary. Does everyone see the screen again? I'm sorry, guys. I'm so sorry. I don't see. I'm looking at the slides right now, and so I don't see what's being broadcast, and I don't understand why that suddenly. So you can see what happened here. This crashed. That screen crashed, and so that's why this is having some trouble here. But I guess we can't go back to the terminal just yet. Right. So anyway, but what I was saying though is if you go to the back to my slides here. So this is the please install your software here. So we're basically looking at this stuff here. These are the links that you might want to look at to install your GitHub and Git and everything. And so that would be, please look at these things by the time we have lab on Friday here. And come with questions. If you do have questions, let me know, and we'll see what we can do to solve these things here. Lab is also going to be online. In fact, they're going to be online all semester. It's the same link for class, and so you can just if you pulled across the calendar. In fact, maybe I should talk about that for a moment here. Hopefully everyone here has actually had time to pull across the calendar. I'm going to give you the link to the calendar so that in case you still don't have it here, you get a shareable link. Okay, so I'm going to the chat right now, and this is the calendar link that I have. And basically what you do is you click on that, and that will give you a copy of the calendar in your calendar. So that means that you can see when the classes are, you can see when the lab is. But more importantly, I know you can remember, you know when the classes are, and you know when the lab is. But more importantly, though, in each of those daily events, there's a link to the Zoom, which I think is probably more helpful. It's helpful to have that information here. So anyway, that's there. If you need any, if you have any trouble getting that to work, then please let me know. Oh, it has the labs, but not the classes. I'll have to look into that and see why that is. If you check up on later on, if you check up later, the classes should show up. I'm writing that down now. I don't understand why that would for lab. Well, anyway, I'll look into it and find out why the classes are not there. They should show up. I'll let everyone know. Now, what I would like to do though is I would like to revisit this the article that we went through at the end of class on last class here. And so let me just go ahead and make some space here. This is the article that I wanted everyone to look at here. But this is one of those articles that when you read this thing, you suddenly have this sense of, it's like you start shaking. It's like you feel kind of creeped out in some way. And the article, I hope you've had some time to read this thing here. I'm going to ask you to go into some breakout sessions in a bit here and discuss some questions. But the article basically concerns taking the smartphone information or the location that your smartphone is pinging out. I mean, you have your smartphone in your pocket, so your smartphone is pinging out where it is, which basically means where you are. And it's putting out that information for some of the apps or some of the other, some of the functionalities that the smartphone has. Now, you're probably thinking, well, why does a smartphone need to ping where it is? I mean, who does that? I mean, it's not like we go to the store and I'm in aisle 5 of Walmart. Nobody does that, but your smartphone does that because when your smartphone is checking, say, like the weather, it needs to know like what town it's in, and so that's how it knows what the weather is. And we use the weather app all the time. We never think that that's a that the weather app is somehow finding out where we are, but it needs to know where we are. But also, though, your cell phone or your smartphone inherently needs to know where it is, and it needs to ping that address out, because it needs to find the next available tower, or it needs to tell the towers where it's going, so that it can start talking to the next towers, and it makes communications much more efficient. There's some engineering involved where it needs to know where it is so that it can find available towers, so that it can actually send the data signal. So what I'm trying to say, though, is that you have all these apps in there. Oh, and by the way, when when you take a picture, for instance, and ping it to someplace, again, you're sending information about your latitude and longitude embedded in that photo. It's in the metadata, and so your phone is really making no secret about where it is at any one time here. And so these points that we see in this article, and you hopefully have this on your own screen now. I'm just going through this for the slides. These points are the locations of people who have smartphones in their pockets. I think that there may be some overlap here where we're actually looking at the same person multiple times. But you can see, though, that if you didn't have this image of the Pentagon underneath all these points here, you could still tell where the rooms are, because you can still see where these points are gathering. Remember, people gather in rooms or hallways. They don't gather necessarily in the streets. And so looking at this picture here, look at how the points are kind of congested, I would say, inside the Pentagon, whereas the roadways on the left side here has just a few points, and they're all in a line, which suggests that those phones were in cars as they were giving out information. And so this is a visualization in data analytics here. It's a visualization. All these points here have been kind of turned into graphics, and so now, and overlaid with other graphics, and now you're able to make sense of this. In fact, we make sense of visual cues very, very readily, and that's one thing that our brains are very, very good at doing. And so in this particular case here, when you're doing kind of an analysis of where phones are, you can just look at the graphics, and it speaks loudly. In fact, it speaks more loudly looking at it in graphics than if you look at these in numbers. Anyway, but this whole article is about these. In fact, you have these other pictures here you can look at. I think this is the White House. Isn't this juicy? But you have the White House pictures here. You can see that not very many people in front of the White House, but many people inside the White House. And so again, if you didn't see that there was actually a building there, you could still tell where it was just by where the congestion was. But this whole article, I know it seems like some kind of conspiracy theory type, crazy X-Files type of article here. But actually, though, the article is mentioning that maybe, for instance, we don't want to have, maybe we shouldn't have so much tracking done so readily. The article begins by talking about how these companies out there are just kind of like using our location data as they're just pulling our location data from our phones and just using it. But remember that this course has an ethical component to it. And so what we're here to talk about today is about some of the problems which may happen from pulling someone's phone information, like their location information. And primarily, we're talking about the privacy issue here. Maybe I don't want people to know that I'm going for a meeting someplace in some building. Maybe I don't want them to know. But you're probably thinking by now, though, that going back to these points here, how can you possibly tell whose phone is whose? I mean, all these green points, how can anyone really know anything about what about who's going where? Well, they address that in the article, which I think was the piece that gave me the creeps. And that is that, where is it here? Okay, so we have in this graphic here, it says 10,000 smartphones are tracked in Central Park, and they choose one. And remember that every cell phone, every smartphone has its own numbers, its own. There's a serial code in that ping, so that you can say, I know now that this is the same ping that I heard before. It's the same phone. But when you track one phone, going down here, you can see that this one phone that you look at here, this is where that phone has been over the course of maybe, I think it's a week. Reveals, well, not a week, maybe it's more time than that. But basically, though, if you just look at one phone and you watch for that one phone and find out where that one signature is coming from for for some length of time, you'll see that these roads are where this thing came from. And so this could be your phone. This could be your phone. And if, for instance, one area in this map here is a place where you're not supposed to go, and I found out that your phone has this specific serial number or ping code or whatever it may be, a serial number, I guess, and I found out that you've been going to certain addresses here, then it's like I'm spying on you, and you might think, well, that's just not right. You shouldn't be spying on me. But the thing is, though, that unless we start having conversations about this kind of thing, when we're developing the software, some of these problems won't actually be stopped. And not that I'm saying that this is necessarily a problem in some cases here, but we would all think it's really weird if we get into a car and we find behind us there's like a black Mercedes with tinted windows, and everywhere you go, it's following you around. And then you go to the store and you get out, and two guys in suits get out and they follow you around. And then when you go to the let's say you're going to get, I don't know, a candy bar and a bag of popcorn. You go to Walmart and get a candy bar and a bag of popcorn, but you're looking at two or three different types of candy bars, and those guys in the suits come up right behind you, and as soon as you put back a candy bar because you realize it has too many calories, they pick it up, they look at it, and they write down how many calories, they take a picture of you, and then they look at the candy bar again, they look back at you, and then they put the candy bar back, and then anything else you touch in the store, they follow you around, and they keep taking pictures of you. We might think that's a little weird. Just a little. But that's exactly what our phones are doing to us when we go shopping. I mean, everywhere we go, it seems online, everything is being left behind for companies to look at, and all the data is being left behind for companies to look at and process and figure out where we've been. And this is just a bigger scale of data here, where it's actual from physical locations, not like actually locations online, but actually your physical whereabouts. And so there's something else moving down here, another graphic that I wanted to show. In fact, I just like looking at these graphics if you want to know the truth. But this graphic that I'm looking at right now, where it's called Senior Defense Department Official and His Wife Identified at the Women's March. Now, this is actually a piece of analysis to find out whose phone is whose. Of course, you have many, many millions of different phones out there. But if you think about it, you live in a house at a certain address, and you work at a place with at a certain address. And so all they need to do is go to that house and find, like, physical address here, and find out what signals for phones they're getting coming from that location. And they'll probably get maybe a handful. And then they need to go to the place where they know that you work. And then they look at the building where you're working. And then again, they get some signals. And then they just do some kind of cross-checking to see which one phone is common at the place of work, and which phone is common in the neighborhood that they checked. And it has to be your phone because you work at that place and you live at that other place. And so that's basically how they found out this politician here, whoever it was, Senior Defense Department official, and his wife were identified at this Women's March. Now here people are saying, "Oh, don't worry about me. My phone is secure in my briefcase. No one can see it." Well, actually, it doesn't matter. People still know it's out there. It's still sending out signals, and they can still find out where you are because of your phone. And so this, not in this article here, but another article that I was reading about, where, for instance, a similar type of analysis was done, where somebody who was being tracked by it was their ex. Somebody with a database some man was able to track his ex by finding her phone number and seeing basically where her phone was pinging. He had something to do with the I guess the telephone company or something. But he was able to track her like this, and she had no idea. And so, of course, he was able to find out where she was going, and inferring who she was seeing, find out the kinds of neighborhoods that she was going to. She found out that where her kids were going to school. And this is all creepy stuff here, and this is all through the analysis of data. So I'm not bringing all this stuff out to frighten you. I'm bringing this out because you are all going to be going into very respectable careers where you'll be working with data. I know this. The future of our world is filled with data. There will be a computer on your desk where you may have to write some code or you have to do something, but there's certainly going to be data that you have to analyze with that computer. And so it's going to be people like you, though, who actually make some of the rules that we're allowed to play. How are we allowed to use data? How are we allowed to track people? How can we maybe preserve people's privacy in an age where privacy online means nothing? And so I know this sounds like a big weight on your shoulders here. But it's your generation, though. You're going to be the new professional group that goes out there. You will have to solve some of these problems here. And so this whole course is designed to teach you what the analysis will look like, but also to know what it could do if it goes horribly wrong. This is kind of like I think of analysis here as kind of like the research into a nuclear bomb. The research into a nuclear bomb was they were just thinking about the science back when the Manhattan Project was going on. They were probably just thinking about the science and like, oh, isn't this couldn't we break the atom this way or split the atom this way, and shouldn't this, couldn't we apply this formula and blah blah blah. Yes, all the science could happen, but one thing that they were not thinking about though was the expense of lives that occurred from when the bomb was dropped. And that's probably a piece of ethics that was completely left out of the entire equation here. And so what I'm trying to do with this article, and we'll go on to breakout groups in a second here, is I'm trying to ask you to consider that the analysis can be done, but also to consider maybe we shouldn't do this analysis, or maybe this analysis could be done, but maybe there should be rules onto how that analysis can be done or who can do that analysis. Maybe this data shouldn't be available to seemingly anybody, but rather maybe the data should be available to only specific types of groups. But then you might think, well, that's not very transparent. Maybe it should be open in other ways. And so these are problems that you have to work with and figure out, how you can preserve people's privacies, preserve people's lifestyles, and not bother them basically, and not spy on them like this, whatever it is, but provide them with with their personhood intact here. How can they maintain their lives here and their livelihoods and have privacy when people are when they can be so easily spied upon? Anyway, gosh, you guys, you get me all riled up here. So anyway, what I'm trying to say is, heavy lies the crown. When you wear the crown on your head, there's a lot of responsibility. When you have the analysis in your mind here, when you know how to do the analysis, it's there's a lot of responsibility that you have to consider. Ask yourself, yes, of course I can do this, but should I do this? And that's basically what I'm saying. The should question, should I do this, is something that you should always ask yourself. So what I would like you to do now is I'm going to put you into breakout groups. And I have some questions I'd like you to look at here, which are basically these ones right here. I've even highlighted them in nice, there's baby blue text with this nice kind of greenish background. It's supposed to be kind of a maritime, soothing color scheme here. But basically, I want you to consider these questions here. Why is smartphone location data considered to be sensitive or confidential? Not in terms of everything that we've just discussed here, but maybe find some other reasons for why it might be sensitive or confidential. Discuss any two issues of personal privacy which may be likely discovered when this data is analyzed. I mean, what could go wrong when you analyze where somebody went? Maybe something really, really bad could happen. How could the found trends in data be used in unethical ways? Who could gain or lose something? I mean, I say something here. I mean, either they lose trust, maybe they lose wealth or money, or they lose treasure, or maybe they lose data, or maybe they lose a sense of they lose their privacy. Who knows? Try and find out like other things that people could lose. After reading this article, what concerns do you now have? Data that you have? What concerns do you now have that you did not have prior? I think I made a mistake in the writing of this thing here. I just got too excited as I was writing this thing here. But what concerns do you have now that you did not have before reading this article? In other words, how did this article impact you as an individual? What I would like to do is we'll go into our breakout groups. We will spend maybe, I don't know, when does class actually get out here? Is it 12:20? So I think that we'll spend maybe 4 minutes perhaps in this thing, and then we'll come back and have a recap. And then if we don't finish today, then we can come back on Monday and maybe we can still talk about what we've discovered in our groups. But perhaps in each group, though, one person could discover, or could be the speaker for the group here. I'll make 4 groups here, and choose somebody, just like say you're the speaker for the group here, and then that person may be that's the person who writes things down and then answers some of these questions here. And then we'll go after this to the rooms, or from group. Well, when we come back here, we'll answer a couple of these questions here. Alrighty, I'll see you in your groups. I'll make my ways around. So I'll see you there. Take care. Open all rooms. Boom.
Well, it's not that they were trying to. They were definitely trying to get it banned because like people were like military personnel were using TikTok on their like stations, and that's like confidential. And that you have people just using TikTok willy nilly at their army base as giving away their location to like other organizations. And that's bad. I feel I definitely agree with you.
I mean, thinking about location exploit, other things that would resemble like what I've been like ankle monitors, that's like considered an ankle monitor is put on and like house arrest. And so like watching like patients, like and then when you think of like dystopian things like having chips implanted of people, that's considered like the whole privacy and thing. I mean, I'm thinking about like we are so accepting of like smartphones, but when they put it in like other terms, like, oh, you have a chip implanted in you, giving your same concept.
Yeah.
Yeah.
I think the different ones for so many like personal things that we're like, oh.
Let's see the next room. Main session. Is there anybody in this room here? Is anyone awake?
We're here. We were just discussing.
I don't. Sorry, I don't see any cameras. I'm just like wondering, like, did everyone fall asleep? How is everything going?
Good. For question one, we kind of talked about like if people have like private things they like to do in their life, like they don't want people to know where they're working or make like a certain stop at things, like kind of become like known, or like we discovered like personal privacy, like let's say someone's having an affair, they're making like a stop once a week, stopping at. It kind of brings up the question like, oh, why were you stopping that?
That's true. That's absolutely true. One example, actually, that I read about recently in the news was that somebody was about to be hired for a CEO in some company, I forget what it was. It was some company, a CEO. It was a big position though, and the person was being basically tracked in some way. And they found out that this person was going to some kind of he had a kind of a cancer. It wasn't a big cancer. It was a minor cancer, like a melanoma, which could have been easily fixed. But still, because he didn't mention that he had any kind of terminal disease like that. I mean, they thought it was terminal, but actually not all cancers are terminal. People survive very well without or with cancer. But because the company found out that he was sick or whatever it was like that, they thought he was sick. They resent his the offer for his I guess for his application to be the CEO of the company. And that was just by following him around. They just said, "Oh, you've been untruthful. You haven't told us what's wrong with you," and blah blah blah. But for him, though, it's like he said, "How did you know? How would you know about that? I mean, that was a secret." Anyway, no depressing there. Anyway, I'll leave you to discuss. I don't mean to monopolize your conversation. Sorry about that.
Have anything on like unethical ways or like how you could gain or lose something?
That one. Okay.
I think there could be a game like small.
They can read all of that.
Even if we were at our goal, which is obviously anybody's assumption, but like even assuming that they're not gonna, do anything necessarily evil with that information, that doesn't mean that people will access it. I think that's something that the like issue of ex-boyfriend tracking, his ex-girlfriend thing, like that stuff is really not that hard to access. In like the growth, the open hackers, possibly firewall, that outside of like obviously like we're talking about ads, it's less overt like malintent, like it's like they want your money and somewhat understandable. And thinking about human trafficking and also law enforcement even they can just access that sort of stuff and find you if they somehow, which is completely insane. Like, it's not like these companies don't have the budget to make that information weird and hard to get to, but it's also not that hard to break through that.
Yeah, I mean, like look at like Equifax, company like tax. Someone got 3 million people's social security numbers. So yeah, definitely can be done.
Yeah.
I just think like it's just wild how like so much of technology has begun to like I guess center around like surveillance, making sure.
Yeah.
I think
Watching
that's kind of
everybody.
wild.
I will say I like what I'm hearing, guys. I think you have some terrific ideas. I don't mean to cut in here and interrupt and monopolize your conversation, but Claire, what you're talking about is actually a really important idea. And Liam, you too. These are very important ideas. I think Daniel, you also contributed. They're very good ideas. And basically, the thing is though that it's not easy, or it's not difficult to actually do the analysis. But we need to. It's also not difficult to pull a trigger. But we need to ask ourselves: is that really what we need to do? Is that really the right way of the right course of action? And so I think that you'll find that this course is talking about the analyses of things here, and it's not difficult to do these analyses here. But the question that'll keep you up at night when you're in your professional lives here doing analysis is asking yourself, wait a minute, what's the ethical approach to actually doing this analysis here? Should I be doing this? Is this right? Will someone lose their privacy? Will I have any trouble here? Anyway, I've got to move on to the next room here. Thanks for the heads up there, Claire. I'll see you in a bit. Thank you. Okay. Breakout room, fill rooms. I'm trying to think whether I think we still have some people out in some of the groups here in the rooms here, so I'll just wait for them to come back. I'll wait for the other people to come back from their groups here. I think you can still let's wait for a second. 3 seconds, 2 seconds, and 1 second. So now everyone's returning. If everyone's back here, I think that I heard some really good things. Would it be okay with everybody here? I think we're all back in from the main rooms, from our rooms here. Would it be okay if we, if your speakers actually kind of discuss some of the things you recap over some of the ideas that you discussed on next class? Would that be okay? I mean, it's 12:22 right now, and it's just too exciting, and I just don't think I'll be able to stop myself. If it were up to me, we'd be talking about this like all afternoon. But I think that maybe some of us have to go and have other plans here. And so maybe what we'll do is we'll break here then. But when we come back from the weekend here on Tuesday, then we'll spend some time to go through some of these things here. By the way, next week I've just added some updates here. Next week we're talking about website analysis here, which I think you'll find is absolutely fascinating here. We're not just now, we are the people in suits running around the store, watching people and seeing what they click on and what they pick up, what they're purchasing, but actually we're following them around in a virtual sense. And so we're actually following these people around on their websites. And so I'm going to show you how to do all that next time here. These are some other links you can click on over the weekend if you're just dying to see what's going on. These are some like online types of analyses systems here, just so that you can get an idea about what to expect. But we will be covering all this up here. But I'll be sure to spend some time on Tuesday to cover some of the feedback that your groups have come up with. But I will say though that I really liked the ideas that I heard from going from group to group here. I think you have a really good knack for kind of seeing through all the fuzz and lights here and seeing really what the essence of the problem or the nature of the problem is. And I think that that's actually a very good skill to have, especially in data analytics here. Are there any last questions for me here today? Is there anything else I can do? If there's no more questions, I think we might make a break here, and then I'll see you all at lab on Friday. We're probably going to be doing some work with Git, and so please do install your software that you've been that we've been talking about today. Like install your Git, your Docker, and get your account on GitHub if you haven't already done that there. And then in lab, when I give you the lab, it'll basically be an assignment sheet. There'll be a link that you click on, which will then pull across a repository. Which is just your workspace. Okay, but I'll tell you more about that when we get to lab here. But in the meantime, please do install your Git and have your GitHub account ready, and Docker if you have the time to do that. Alrighty, everybody, it's been a great week. Keep going. We're almost there. And by the way, look out for the mail that I'll send you over who's in which group for next week's in-persons. Alrighty? Perfect then. Take care, everybody. Stay safe. I'll see you all very, very, very soon.